So we are still working on predicting pH of solutions. And Jasmine, we started out with talking about getting the pH of strong acid solutions. Now, what's the equation for pH? pH is the negative log of just the H plus. So if you want to get pH, you have to get, Allison, the H plus concentration. What was the trick to getting the H plus concentration if it's a strong acid solution? What was the trick to doing it? Yeah, the strong acid, so what would be the same? Concentration of the H plus would be the same as the concentration of the acid. Exactly. So those were starting out, we're getting pretty confident, right? Things are going good. And then, Gabby, along came weak acids. How did we get the pH of a weak acid solution? Yeah, how do you get the pH for a weak acid? What was the game plan for that? What do we have to do? We had to make a what table? Ice table for a what reaction? Ka reaction. So you had to know how to write the Ka reaction for that, for an acid. Then you had to do ice on it, and then everything that followed from ice. So now we're talking about getting the pH of a weak base solution. Okay, so we have some weak bases. So kind of the same story, but to me the question comes down to, Danny, how the heck do you know it's a weak base? Oh, okay. So you could have something that doesn't have an alkali metal OH. So that what she's saying is that it's not a strong base. Okay. But what if you had a compound that looked like, I don't know, how are you supposed to know, anybody, that that thing is a base? I put that in water, and the pH is going to be what? If it's basic, the pH has to be above 7, right? So the pH is going to be above 7. How do you know that's going to be a base? Ooh, answer's easier than you think. It's in the table, right? So I guess there's two clues. One is that it's in this base table, right? That's one clue. The other clue is take a look at all these formulas. There's a clue that they're all bases. What's missing? The H in the beginning, right? Because that's kind of their convention. That's one general way of finding an acid. It doesn't always work, but it's a good clue. So, yeah, they're all absent. So these are going to be bases. But it doesn't really matter. They have to be in the table. Okay. So that's pretty much, for now, how we're going to figure out these bases. They got to be in the table. Not going to be the story next class period, but it works for now. How should we write a base ionization or hydrolysis reaction? Now, Crystal Munoz, before we called it acid dissociation. Yeah, because the hydrogen ion just kind of fell off. Didn't fall off very well, but it kind of fell off. This is an actual reaction. And they call it hydrolysis. So those bases in the table, they're going to be reacting with something, but they're a base. So they have to produce what? If it's a base, it has to produce hydroxide, right? If it's a base, it had better produce that. So when we write these, they're called hydrolysis reactions. We don't call it dissociation because the OH isn't falling off. That base has to react with something. What is it reacting with, Erica? What is it reacting with? All these reactions, all this hydrolysis stuff, it's all occurring in water. It's reacting with water. So it's going to produce, that base is going to react with water, produce hydroxide, then Vivian, something else. What's the other something else? Not H plus, because then it would cancel out with the OH minus. You just end up with pH neutral all the time, pH 7. Ooh, what do we call it? Conjugate acid, perfect. We're going to produce the conjugate. All right, can you see what's happening here? Because H2O is really HOH, right? That base, this base in the table, just grabs one of these, right? It leaves the hydroxide, great, but then forms a conjugate acid, okay? So that's what's going on. The base grabs an H off of a water molecule, forms conjugate acid, leaving hydroxide. Now it's weak, so we should have a double arrow in the, right? It's big time on the product side. So the arrow should be going that way, the little one this way, but no, that's okay. Okay, so we have an equilibrium constant for that reaction. I call it the Kb reaction because my equilibrium constant is Kb. It would be what over what, Diana? It would be what over what? Product over reactants, which would be O in brackets. What do the brackets mean again? Concentration. What are the units of concentration? Anybody? Molarity. Okay, keep going, Diana. You're doing good. Oh, I forgot to write. She said conjugate acid. Conjugate. I got to catch up with you. Conjugate acid. Okay. Then the base in the table in brackets. Yeah, she caught it. Right? H2O is a liquid, so you don't leave it in there. Right? It's any liquid has a concentration, like water's is 55.4 molar. It can't change, otherwise it wouldn't be pure water. It wouldn't be H2O liquid. So anyway, products over reactants. Leave out solids and liquids. Because you know, we're lazy. We're supposed to be writing subscripts on stuff. You can't see yellow. Oh, like the base in the table, subscript, you would probably write AQ. Everybody for water, you'd write L, good, for liquid. Hydroxide, AQ. All ions, AQ. And the conjugate acid, AQ. Okay. So where do we get these Kb numbers, Danielle? If we're going to do ice and we want to use this stuff, we're going to need a number for Kb. Where do we get those? In the table. Yeah, in the table. All right. They're all there. Oh, hey, since we just got off, Alyssa, we just got off of this Ka stuff. Are there any Kb's in there that look like, oh man, I'm going to have to do the full quadratic formula? She says no. Does everybody agree? Yeah, we can drop the x every single time as long as we stick to this table, right? Nice. Well, we'll see how things go here. So write the hydrolysis reaction for ammonia. And then we'll write its equilibrium constant expression. So Crystal Zamora, how would you write the hydrolysis reaction for ammonia? NH3 plus H2O goes to OH minus. Perfect. Yeah, you're right. Because you have to add an H plus to it. So the convention for ammonia is to add it to NH4 plus because we call that ion ammonium. But a lot of folks like to put that acidic hydrogen out front, so they might write HNH3 plus. That's fine. I don't care. Just need 4 hydrogens. Oh, we need the equilibrium constant expression. Tegan, how would you write that? Kb equals, in brackets, perfect. Okay. Sounds like we're good to go. Let's work out this one together, though, before we go to the boards here. Find the hydroxide and the pH of 0.01 molar C5H5N. I believe from the table that's pyridine. Jasmine, how would you start this out? Okay, write the chemical reaction. What chemical reaction would you write? C5. Done? Did she miss? She missed one thing. What did she forget? Well, she changed the 5 to a 6. That's okay. She has her H in there. She just forgot the what? The plus. So you have to add an H plus. So some folks, you're right, some folks might have wrote it as HC5H5N plus, but it doesn't really matter. I kind of like writing it this way because it's more obvious that it's a conjugate acid, but that's okay. It works. It all works. So ice. How would you fill out that initial row, Allison? Under the, yeah, we're doing the I row, the initial row. Yes, under the pyridine. Okay, blank or dashes. Now, is there a compound, Gabby, that we can just put dashes all the way down for in this table? Which one? H2O. And it's a really good idea to do that because you're going to be really tempted to put an X or something in there. So just put dashes all the way down because it doesn't show up, right? Concentration is constant. So Danny, how would you finish this table out? Minus X. Yep. And then we just, everybody, we just add them up, right? 0.01 minus X, X, and X. So Crystal Munoz, do you remember when we did these Ka reactions, we got our little X, and that was a concentration of H plus or OH minus when we did those Ka reactions. Do you remember? It was the H plus. When you write a Kb reaction, our little X, Erica, is going to be the concentration of yeah, if we did, well, look at this. If you do, don't worry about that one. Just look at this one. Here's our Kb reaction. You draw ice, make an ice table. You find, we're going to go through some work, a lot of work to find our X. Great. That'll be the concentration of what? Anybody see it? It'll be the concentration of OH. Right? So when you do these problems, just realize X is not the concentration of H plus. X is the concentration of OH minus. Okay. Well, anyway, Vivian, now what? Set what up? The Kb, what do we call it? The Kb expression, the Kb expression. Okay, so Vivian, how would you do that? Reactants. Well, what's the Kb number first? Let's write that in. Okay, and that's going to be what over what? She wants to jump to x squared all over. Or could we just write 0.01? And if you write 0.01, you should be careful with your notation because it shows better understanding. You can write a dot above the equal sign, Or you could write a little squiggly stuff. What do these mean? Either one. It means approximate, estimate, right? Not exactly equals, but it'll be really, really, really close. Okay, so go ahead. Get your X. Figure out what the hydroxide and pH will be. Yeah.
So what's the formula to get the pH?
Okay. For me, the easiest way is whenever you can use pH plus POH equals 14, it's easier. Now, you can do it that way, or you can do it the way where Kw is 1 times 10 to the negative 14 equals hydrogen ion times hydroxide. That seems to be more work. Because I like doing it this way. You have this number in your calculator, right? So if you just push what? You have POH. Push the log, and you have a POH, and there's a negative sign in front of it. It's all set up for you to subtract from 14. So add 14, and boom. Yeah, because you're going to, when you take log of this, you're going to have a negative answer. And I got about, yeah, thanks, 8.57. So let's say, Jarixa, man, you're just flying on these problems and it's just going great. Ooh, man, I can turn this quiz in super early or the exam super early. You can look at these and pretty much tell whether you got the right answer or not. Is this the right answer, logically? Why does it make sense? It's supposed to be a what? This solution should be what? This is a base. So the pH had better, I don't care what the concentration is, the pH had better be what? More than 7. And it is. So that doesn't take but a second to look at. Because if you screw up with the x squared or screw up with the math, I guarantee high probability you're not going to get a pH bigger than 7. Okay. So we can go to the boards, knock out these problems, and you guys can have a good weekend. All right, let's try it. Get you confident with this stuff. Take this times that.
Take this times?
What are you doing? This over that equals this.
No,
so take this times 0.01.
I got the X.
Oh, you got the X. Okay. So this is what? The concentration of OH. So take the log of this.
Take log.
Okay, that's the POH. So that's POH. So 14 minus POH is,
Okay, so then, take log.
then that's POH.
That's
And then,
14 minus.
so just really just add 14 to this because it's already negative. And there's your base, there's your pH. So find the hydroxide and the pH of 0.05 molar ethylamine. And the Kb is 4.7 times 10 to the negative 4. technically you should have a plus here. But notice how it doesn't
yes.
doesn't really mess up your ice table.
Yeah, I did it here, but here.
Yeah, doesn't really matter which one. And notice how it doesn't screw up the ice table at all anyway.
Yeah. You know, my book is defective.
How can a book be defective?
I'm missing pages.
Really?
I don't have those.
Oh, you're talking about the book that you bought.
Yes, this one. That's my page that starts off.
Man, you got ripped off.
I did.
Too bad there's no money back return policy.
There should be. I'm gonna write it down.
Yeah. Sorry. So this is 4.5 times 10 negative 3, right? So that equals a concentration of what?
OH.
OH. So what could you do then?
Now to find a pH, press log.
And that would be POH.
Add 40.
I see a lot of 11.7s as the final answer. Make sure you can get that 11.7. I want the folks around you can help explain it to them. So this equals what? Write more. If you get lost, just write more. That has to equal brackets OH minus, right? And then we have all these equations on the top of the quiz. We have POH is negative log of 14.
Okay,
Sorry,
so
POH is negative log of OH,
so I
right?
take this and I take the log of it.
Log of it, and that's
So
POH.
14.
Yep. Okay. In EX4, when you get that far, in EX4, there's no calculation. EX4 is a conceptual question. Good. Okay, that's your hydroxide. Oh, you got it. Good. You got it. Okay. Sorry. So in EX4, you need to circle the solution there that's going to have the lowest pH, and draw a box around the solution that will have a highest pH. Would you guys have your answers for EX4?
Yeah, they didn't. They erased it.
What did you have as your answer? Well, write it down so then we can all see if we can agree. Do you have an idea? You have an idea? You're going to use the table's a big hint. You got to use the table to answer EX4. What numbers? The KBs, all right? So if you have a bigger KB in that table, what does that mean? Right? If, no math.
KB means that your OH is
That means you have more OH. Okay, now if you have more OH, that means the pH is higher. That's the thinking for this. Good. That's the thinking for this number 4. A bigger Kb means that there's more product.
Higher pH like toward the base one?
Well,
Like,
back up. Bigger Kb means more hydroxide. Everybody agree?
Yeah.
Okay. So if you have more hydroxide, that means the solution is more
Acidic.
basic. And really basic pH is high or low?
Basic?
Really basic pH is, yeah, really high. So that's why we say higher pH. You could say more basic pH if that makes sense. But
So bigger KB
right, that might sound better, right? More basic pH. And that means a higher pH. All right? So see if you can figure out which one you would circle and which one you draw. You circle 2 of them. See which one you draw a circle around and which one you draw a box around.
excuse me.
So write your answer up there. Oh, well, use Erica's. Well, did you get an answer for this one first, Gabby? Or the one we're on, EX4? Oh, write it down so I can see that everybody agrees. So which one has the biggest Kb out of this bunch? The one with the biggest Kb is? Now you guys aren't all agreeing. C2H5NH2, ethylamine is, where'd it go? 4.7 to 10 negative 4. The other one was, see this is bigger than, right? This is a bigger number.
Yeah.
That's bigger than 4.4. So ethylamine should be the biggest one. So you should be drawing a box around ethylamine. Which one do you circle? N2H4? You agree?
Yes.
Okay.
So which one's the highest?
Okay. So when this makes sense to you, go on to the big test. The big test is about as ugly of a problem as I can give you. It's not that bad. You have to think about it.
Yeah. So we use pOH, outside pH. I was thinking pH.
I'm on the right track.
Yeah, different. That's what I was thinking.
So you got the hydroxide concentration.
And isn't it the same as whatever the conjugate acid is?
Ooh. Right?
And then somehow you...
Because, now how did you get this expression?
Oh, the KB, right? It's going to be...
Right?
Yeah, so it's going to be this over
Yeah.
the OH. and
Yeah, so
then
the only
conjugate
thing, this
acid.
looks good. The only thing that you're kind of missing that to show that it makes a lot of sense to you is right the KB reaction.
Okay.
But other than that, it looks pretty good. And technically, this should be this minus x. But it's 10 to the negative 9, so you drop the x. Right? So see if you can get this, and then I'll help you out. You can do ice. It'll help you to do the next step if you do ice first.
this is pH. Use pH for OH concentration because basically. And that equals our OH concentration. Yeah, if it's 10 to the power of T5, it's past that.
If the pH is this, what is the concentration of this? They're not asking for pOH. It wants to know what is the concentration of this stuff.
So if I did something with this would be the OH concentration.
Hold it. This is the, what is this? This is the pH. You do 10 to the negative that, what do you get? Yeah, what is that expression? Is that the concentration of hydrogen ion or the concentration of hydroxide? No. Write it up on the board so you can see what you're doing. Okay, what do we have going on over here? Okay, now they said that the only thing with this ice table, the only thing that you're missing is that this is the pH. That's the equilibrium concentration, right? So you're putting it in as an initial. That's not right. So don't put it in as an initial. Okay, excuse me. Okay. Let's see if I can get you started here. If you haven't got it figured out.
So if we solve for the OH, our OH concentration, and our OH concentration, is that our X?
In your ice table. That's the trick to doing this. Do you hear what Crystal said? The concentration of hydroxide is the X in your ice table. And once you recognize that, you can solve this problem. So if you make the ice table, you know what X is. It's the concentration of hydroxide. And you can get it because you know what the pH is. So use that pH, use that to get concentration of hydroxide, which is that X right there. All right, that's the big game plan. Because then we'll know everything in that KB expression. We'll know everything but question mark. Okay.
Oh, that's that equation. Like the one.
Oh, this one of the original 7 pages.
Oh, yeah. That.
So pOH is what, 3.75?
Yeah.
So what did you get, Elson, for your concentration of hydroxide? What's 10 to the negative 3.75?
1.78
8 times 10 to the negative 4?
Yeah.
So that, you can plug stuff in then. Oh, let's use this guy. So 1.4 times 10 to the negative 9 has to equal 1.78 times 10 to the negative 4. And you got to square it. Divide that by question mark, essentially, right?
And then you cross multiply.
And then pretty much bring the question mark up here, that down there. Yep.
Wait, so you do the 1.4 times 1.8?
Mm-hmm. Because the answer is 22.6.
Oh.
It's showing.
Oh,
here.
yeah.
Yeah, the correct answer is given. It's 22.6. What's up, Nyla? Okay. Yeah, I got a pile going here.
Do I square it first?
That's what it says. You better square it. All right, thank you very much.
Because you put starting Monday will be you put Saturday, April the 5th, and then on another part you put Thursday, March the you put Thursday, March the 5th, the day of the ceremony. Like.
Oh, okay. I'll look it over and.
Okay, so how do I put that in the calculator?
So, first, how do you solve for question mark?
Well, I would take this and times it by this.
Whoa, this is on top, and that's on top.
I mean, then divide it.
This has to go where?
Bottom?
Down here. Where's the question mark go?
Oh, up there.
Up there.
Oh, okay, got it. Okay, so but how do I do the square?
Right. So you're gonna have to do.
Over 1.1.
So first put 1.78 times 10 negative 4 in your calculator. Hit x squared. Divide by 1.4 times 10 to the 9 negative. 22.6.
Seriously?
Wait, let me write.
You make everything difficult for me.